Hello, today we're going to talk about dimensional analysis and scientific notation. And although those are not chemistry concepts per se, we're going to need them in order to do the chemistry we're going to do in the rest of this unit. All right, so first let's talk about scientific notation. So scientific notation is a way of writing numbers that are either really big or really small, which we often encounter in chemistry. Okay, so for example, the width of a human hair is 0.000008 meters. All right, that's very small number. And so it's kind of a pain, like I was just counting the zeros to figure out how big that number is, okay? But we can move this decimal 1, 2, 3, 4, 5, 6 places. We always move it so that there's just one non-zero number to the left of the decimal. So if we move that 6 places, we would write that number as 8 times 10 to the minus 6th, okay? And so the way I try to remember this is if you have a very small number, much less than 1, then your exponent with your 10 will be negative. And if you have a big number, much bigger than 1, then the exponent will be positive. All right, so for this one, we're going to move the decimal the other way. So you can imagine the decimal is here. It's not explicitly drawn, but that's where it would be. And so we want to move it until we just have one non-zero number to the left of it. So we'll move it 1, 2, 3, 4, 5 times. All right, and that'll give us 1 times 10 to the 5th. Okay, and this number is 1, 2, 3, 4, 5, 6. All right, that's how many times we'd have to move it. And just as an illustration of how we get these numbers, that's 10 times 10 times 10 times 10 times 10 times 10, which is 6 tens. All right, so that gives us 1 times 10 to the 6th. Okay, so that's what the number, the 10 in the scientific notation tells us. Okay. So how do we put this in our calculator? This is a little tedious, and you can just skip forward to the part that applies to your calculator, but generally they fall into 3 categories. They're either a graphing calculator, this is a TI-83, but other graphing calculators will be similar. This is a scientific calculator from Texas Instruments. This is like the ones that I have in the classroom. These are the TI-30XAs, I think it is. And then this is an iPhone calculator. I apologize, I don't have an Android. If you have a different cell phone, honestly, I recommend a calculator, not a cell phone, but if you have a different one that's not shown here, you can let me know and I will help you figure out how to use it. Okay, so the button that we're looking for on all of these is 2 capital E's. So on the graphing calculator, it is here, right? It's in yellow above the little comma button. Okay, so in order to get that button to access it, you need to hit the second button. Okay, so you hit second and then the comma, which is the EE, all right, and then the exponent. So for 2 times 10 to the 25th, or I think the example I did in the notes was 2.4 times something, you would do the 2, then you'd hit the second button to get the EE, and then you do the 25th. Which is the exponent. Notice there is no 10 in here, and there will never be a 10 when you use the EE button, okay? It's included in that function that you are doing times 10 to something, okay? And then the output that the calculator will give you looks like that. So you're going to use, or it would come out as 2 and then a capital E 25. Don't write that on your paper when you're doing a calculation. This means 2 times 10 to the 25th. So you need to convert it back out of the calculator notation. Okay. The next is our scientific calculator. Very similar. It's still this EE button, but we this time don't need to press second because it's already there. So you want to take a look at your calculator and determine, is there already just a button that says EE? Okay. Or do you have to hit some other button to get access to that function? So this would be just 2 EE25. The output for this one looks like 2 to the 25th, okay? That is not what it means. It means 2 times 10 to the 25th. So you have to understand what your calculator is telling you. All right, and then for the iPhone, again, it has an EE button. You have to turn it sideways in order to get that function. So again, it will be 2, the E button, and then 25, which is your exponent. And then the output there, sorry, I'm covering it there, is going to be 2 with a little e and a 25. And that means the same thing. All right. So now, let's do a couple of examples of conversions. Okay, so we are going to use a technique called dimensional analysis, but in order to do that, we need conversion factors. Okay, so conversion factors are just two equal quantities, okay, and then we put them in a fraction, basically. So this fraction, since 60 minutes is equal to 1 hour, or 1 hour is equal to 60 minutes, that fraction is equal to 1. So we can multiply it by a quantity and not change the value of the quantity. We could just change the units, right? So for 1 meter and 100 centimeters, we could get these conversion factors. And then if the conversion is squared, so if we have a square inch instead of just an inch, we can actually imagine doing, so a square inch is just 1 inch times 1 inch, right? So if 1 inch is 2.54 centimeters, we can do 2.54 times 2.54 and get centimeters squared, all right? And in order to accomplish that, you can just square the entire conversion factor, which is kind of a nice feature. So 1 inch squared is equal to 2.54 centimeters, the whole quantity squared, all right? And then the same is true if it's a cubic inch. If you're doing 1 times 1 times 1, it would be the whole conversion factor just cubed. Okay. Sometimes when you do problems like this, the conversion factor is given to you in the question, and that can be a little bit tricky. So if we have a motorcycle traveling at a speed of 85 mph, that means miles per hour. Anytime you hear per, you've got a conversion factor. So this means that in 1 hour, this motorcycle drives 85 miles. Okay, so 85 miles and 1 hour are equivalent quantities for this conversion factor. Okay, similarly, if we have a vitamin tablet and it contains 500 milligrams of vitamin C, we can write that as a conversion factor. Okay, so we can say that one tablet is 500 milligrams, or there are 500 milligrams in one tablet, depending on which one suits our purposes. Okay, so now let's use these conversion factors. So when we have a problem, how are we going to do it? All right, first we want to identify what we were given and what we're trying to find. Okay, so for this problem, how many inches in 1.5 feet? We were given feet and we need inches. Okay, so our plan for that conversion must rely on the fact that we have conversion factors to get from one to the other. I will always give you these conversion factors. You do not need to memorize them. All right, but I know the relationship between a foot and an inch, right? There are 12 inches in a foot, so I know I can go straight from feet to inches in one step. Okay, and the conversion factor that I'm going to need is 1 foot is equal to 12 inches, right? And then the last step is going to be to set this up. So the number that's given in your problem will go in the front, right? The conversion factor goes next, right? And it's important that you write the units so you can keep straight what you're doing, okay? So if we're starting with feet, we want those feet units to cancel, so they'll go in the bottom of our conversion factor. And the units that would then be left, if we cancel out the feet, would be the inches. Okay, so that's what will go on top. So what you're trying to find, or what you need, is always the unit on top, and what you were given is always the unit on the bottom. Okay, so for this one, then our conversion factor would be 12 inches over 1 foot. When we do these problems, remember this is like a numerator, so we multiply all the numerators, so that's just 1.5 times 12, and divide by all the denominators multiplied together, which is just 1 in this case. All right, so that gives us 18 inches. All right, so how many centimeters in 1.5 feet? Well, I know how many centimeters are in an inch, and I know how many inches are in a foot. So if I'm going from feet to centimeters, I'm going to do it in 2 steps. I'm going to go from feet to inches and from inches to centimeters. Okay, and the 2 conversion factors I need are 1 foot equals 12 inches. This is what we just did. And 2.54 centimeters is 1 inch. Okay, so to set this up, 1.5 goes in the front, just like before. 12 inches and 1 foot, right? We want those feet to cancel. And in our first step, we're going from feet to inches. So since inches is what we're trying to find, it will go on the top. Okay. In our second step, we're going from inches to centimeters. So in our second conversion, inches will go on the bottom because we're trying to get rid of that and we want to get to centimeters. All right? And so then 1.5 times 12 times 2.54 is the top. The bottom is just 1 times 1, which is 1, And so we get 46 centimeters as our, after our conversion. All right, so that wraps up the conversion factors, but the thing you want to keep a close eye on is making sure that your units line up so that the things you don't want in your final answer cancel out. And I'm not talking about the numbers canceling out, just the units are just the words after the number that tell you what unit you're in. So are you in feet, are you inches or centimeters or miles or minutes or whatever it is. Those are all units.